Today I'm going to talk to you about ratio, and I'm going to look at some facts about ratio. So ratio, they are used to compare quantities. So for example, for every 1 part of water, you might have 4 parts of coolant or something like that, or you could be 1 cup of orange juice to 4 cups of water or something like that, but they are always in the same units, and we write a ratio using the 2 dots, 1 to 4. Sometimes you can write that ratio as a fraction, particularly if you're trying to compare this ratio, find out if it's the same as another ratio. We could write that is 1/4 and use that to compare with another ratio. Let's have a look at how order is important. So I'm just going to draw a quick picture. Let's imagine this is a cliff, so we're dealing with a cliff height. Let's suppose the cliff is 80 metres, and then this is much longer, not to scale, but there's a boat over here, and let's suppose that that's 3.6 kilometres away from the cliff. And let's write down what the ratio of the height of the cliff is to the distance of the boat from the base of the cliff. So let's just go height of cliff, I'll just write height cliff, so I know what I mean, to boat distance. Okay, now I've set the order that I want to do the ratio, but the thing is, these two aren't in the same units, so I need to convert them so that they're in the same units. So this is easier to write in meters, so 3,600 meters, and I already have my cliff height in meters, so we can write 80 to 3,600. Now that's not very easy to interpret, so what we want to do is try and simplify this ratio as much as we can. And it just so happens that these numbers both divide equally into 80, which makes it easier to interpret. It's not always possible to make it nice whole numbers with a 1 to something. If I divide both of these numbers by 80, that's what I did, by the way, I get 1 to 45. Now, what does that mean? Well, it means that the boat difference is 40. The distance is 45 times more than the cliff height. That's what it means, and that's because I've got 1 to something. A 1 to something ratio is possible with any ratio, but you don't always get a whole number. If you want 1 to interpret on one side, then you're going to have possibly a decimal number on that side. So it's not always possible. It just happened to be working nicely with the numbers I chose. And we can also look at the ratio the other way around. If I wanted to look at the boat distance to the height of the cliff, then I would get, obviously, the 3,600 to 80, which we know simplifies to 45 to 1, which means that it's 45 metres it's 45 times greater the boat distance than it is to the cliff. That's what that means, okay? The next thing is, let's talk a little bit more about simplifying ratio. Let's simplify some ratios. So I'll pick some numbers, so 36 to 24, for example. We look at those and we think, right, what's the highest common factor of 36 and 24 so that I can divide both sides equally and create a simplified ratio? Well, both of these numbers go into 6. Both go into 12. 12 is higher than 6, so I'm going to divide both sides by 12. Dividing by 12 gives me 3 to 2. Therefore, the simplified ratio is 3 to 2. Which is not the same as having 1 to something. If I wanted to make it 1 to something, I'd have to divide both sides by 3. If I wanted a 1 on this side, I'd need to divide both sides by 3, so I'd get 2/3. Obviously, that's a decimal number. Obviously, I've written it as a fraction, but this is only if you need the ratio to be in what we call unitary form, or 1 to something, 1 to x, okay, where this is obviously the decimal number. It is not the simplified form. The simplified form has to consist of whole numbers, and you have to go as low as you possibly can. So I can't go any lower than 3 to 2. So 3 to 2 is the simplified form. Let's talk about a proportion statement. So if I had 2 ratios, I'm just going to use letters or variables in this case, A to B, and another ratio that was C to D. And if I wanted to know if these 2 ratios were in proportion, what I'm saying is, are they equal? Do they equal each other? If they equal each other, then we can say they are in proportion with each other. And sometimes to tell if something's in proportion, it's as simple as, does it simplify, does this simplify to make that? Or can I use factors that simplify it to make that ratio. And if that's the case, then they're equal. But if you don't know because you've got some weird and wacky numbers, what you can do is you can write any ratio as a fraction. So A over B and C over D. Now, if they are in proportion, these two will equal each other. And to get a statement of proportion, you can literally use the cross multiply method. You can say, okay, therefore AB, sorry, my mistake, AD, rub that out because I'm going across there, AD equals CB. And this is, if this is true, then they are in proportion and they're equal. So let's just do an example of two ratios that possibly might be in proportion. 4:7 and let's go 28 to 49, right? Now, we want to know, are they in proportion? Well, I can use the idea of, well, does this simplify to make this? If it does, then they're the same. They're in the same proportion. So let's have a look. But 28 and 49 go into 7. This goes in 4 times. This goes in 7 times. We can see that this simplifies to this, which means that they are equal. They are in the same proportion as each other. But let's just show that this works with this particular ratio. I can write 4 over 7 is equal to 28 over 49. Now I can now do some multiplying. I can go 4 times 49 is equal to 7 times 28. I think I've just gone off the bottom of the screen, so I'll just pause that and write it up there. Okay, so 4 times 49 is 196, and then 7 times the 28 is 196. Left-hand side equals the right-hand side, hence the proportion. The statements are in proportion. The two ratios are in proportion with each other. You can use this idea if you're told they're in proportion to calculate a missing part of the ratio. So here's an example. Let's use 4:7 again, and let's use x to 15. Okay, we're told they're in proportion, we want to know what x is going to be. It's not as simple as working out, well, what do we multiply 7 by to get 15? It's not a whole number. But we can write them as fractions and use our proportion statement. 4 over 7 equals x over 15, and then do our multiplying. Well, 4 times 15 is 60, must equal 7 times x. So therefore our x is 60 divided by 7. Just checking I'm not off the bottom of the screen. 60 over 7 is x, which we can simplify that fraction down. 60 over 7, both numbers, what do we simplify that to? Well, we can't because 7's a prime number, so it must be 60 over 7. And that's pretty much everything you need to know about ratio.